Good morning everyone and welcome to our presentation today with Sunswift Racing. My name is Alistair Bate and I'm a cloud architect in AWS Professional Services. I've been very fortunate to work with Sunswift for the past 2.5 years, and I think today you'll really see how these are an actual amazing, cool customer. Innovation through partnership, that's the core at AWS. We love to provide the tools and help our customers explore what's possible in the realms of whatever industry they are a part of. And you'll see today that Sunswift exactly does that. They take what's possible to combine it with their mission and to really exceed the bar, pushing through boundaries. And it's very much a two-way street. They help us explore what's possible by giving us new ideas of what they want to achieve, and they can go out and explore what we've learnt with them. So today, as you hear their story, we'll break it down into about 4 main parts. Their mission, what they're trying to achieve, which you'll very much hear today. The challenge, very much a challenge that they try to achieve as part of the Bridgestone World Solar Challenge. The technology, what to actually feed into this amazing car and the technology that they produce to perform as a well-performing team. And of course, the advanced technology and how they work as a team to get to the result. And what I do challenge you to think about is how it actually applies across industry. Today we may be thinking about the Bridgestone World Solar Challenge and how they've applied it to an automobile, but this can apply across many different industries. From IoT, to media life, to data, it's all really there. But you're not here to hear me speak all today. So I'd like to welcome to the stage the Sunswift Racing team, made up of Zami, Daresh, Luke, and Richard. Each will give a bit of background about themselves as they begin. Thank you, everyone. Well, let's just get started. Thank you guys for being here today. Richard, so what is Sunswift Racing and what's the mission of Sunswift?
Pleasure to be here, Alistair. Thanks very much for inviting us along. Sunswift Racing, look, it's an amazing initiative. I'm going to say that slightly biased as I'm sort of responsible for running the team. It's a group of 100 undergraduate students that operate out of UNSW Sydney in the engineering faculty. And their mission really is to design and build the next generation electric prototype vehicles. And we do that really harnessing those 3 sort of key pillars of education, innovation, and collaboration. And that's kind of why we're here, Alistair, through that collaboration, I guess.
Absolutely, yes. Well, yes, and it's all part about sustainability and trying to change the future, right?
Yeah, look, Sunswift's been around for a little while, but really the mission is to adopt performance, technology and innovation and really wrap it around that sort of sustainability model. So everything we do, we're very conscious about the environmental effect of what we do going forward.
And I guess your background is with F1, but you're really bringing that perspective to the team here at Sunswift. So tell me a bit about that.
Yeah, I background of 30 years back in the UK working in Formula One, where maybe sustainability hasn't always been the good thing. That was maybe the dark side, and I'm on the brighter side of life now working with something that's very clean and very environmentally conscious. But even Formula One is understanding what it's doing and trying to make the same effect. I think we're one step ahead of them though. Exactly.
Well, performing teams is really a big part of this, but today we're here to talk about Sunswift's journey in the Bridgestone World Solar Challenge. So we have a quick teaser of the video and let's let you all watch it now.
Solar racing is really unpredictable and being able to react really quickly is very important. Being able to have our data available to both people on the ground as well as back in Sydney straight away is really important to be able to make operational decisions about how to drive.
We couldn't do what we're doing today without the data. Even as long ago as 2019, it's amazing how the technology has advanced or actually just become available. The successes that we're experiencing here is absolutely in conjunction with AWS.
I was very fortunate to go with this amazing team on that journey from Darwin to Adelaide, and that's just a short clip of the longer video. So after today's presentation, would really encourage you to go and check out the longer case study video about the amazing journey. But for now, let's hear a bit more about it. So Zami, I'll start with you. What is the Bridgestone World Solar Challenge and what's its purpose?
Good question. My name is Zami. I'm the current technical support systems lead for Sunswift. So what we do is kind of, as the name suggests, we, with the help of AWS, design and maintain services that support the car technically. So what is the Bridgestone World Solar Challenge? It's the largest solar car race in the world. It's a 3,000 kilometre race in the middle of Australia from Darwin down to Adelaide. Over 60 teams of university students who come to Australia and compete. So it's really very diverse cultures, diverse engineering disciplines, sort of like an engineering forum for the entire world. Sunswift competes in the cruiser class, where energy efficiency is the most important factor rather than speed. So what that means is that this is a really great way of looking at the potential of sustainable energy. Yeah, it's an amazing way for us to be able to use cutting edge technology like AWS, like solar panels, and really explore the potential of innovation.
I think the big part about the team is that you all come from different disciplines and you get to come around. Do you mind talking through what the different backgrounds of the people in the team are?
Yes, of course. So I am from a computer science background. Duresh, Luke are all similar. Duresh does computer engineering. We have mechanical students. We have energy systems. We have chemical. Have all different disciplines of engineering.
Well, yeah, but I guess this journey just doesn't come together overnight. It's a big, long journey. Richard, you've been here for quite a bit of time. Can you just give us a bit of background about the Sunswift Racing team and where it began and how it actually operates?
Yeah, back in 1996, so we're in our 28th year. I haven't been there from the start, but I've certainly been associated with it for the last 5 or 6 years. I love the romantic story. It's maybe a little bit of romance of a group of undergrad, PhD students and academics who got together one night at the pub and decided to enter this World Solar Challenge, an amazing race, an amazing challenge of not only the technology, but obviously the students as well. So very successful over those 27 years, not only World Solar Challenge entries, but also Guinness World Records as well, and we hold a few of those. I mean, now it's actually embedded within the curriculum, which is the important part. So really forms a structure for all the students to operate within. And I just have the absolute pleasure of going to work almost every day as a proud dad and seeing what all these guys get up to, and as I say, being proud of every single moment of what they achieve.
And it's amazing to see because naturally this is a university subject and students come and go, but you're able to keep that culture moving throughout the entire way. But maybe if we come a bit more closer to where we've started, Duresh, do you mind talking us through what was the year up to the Bridgestone World Solar Challenge last year? What did it involve? What's the complexities? What does it all come together as?
Yeah, thank you, Alistair. First, let me introduce myself. I'm Duresh. I'm the current team manager for Sunswift Racing. But last year, my role was a little bit different. Systems engineer for the Sunswift 7 solar car and a driver on the challenge. My journey started last year around this time with selections for the Bridgestone World Solar Challenge. Obviously, the car had been built at this point already, and it had been built since 2020 and 2021. So about 3 years of real innovation and engineering with countless students. But our journey started with selection for the team and driver selection as well. So we had a bit of a rigorous testing process. We went down to Eastern Creek, did some fitness training as well as some simulator driving to make sure that we had the best drivers going on the competition. And then once this team had been selected, not just of drivers, but engineers and technicians and logistics managers, it's a huge operation. Once everyone was selected, we started getting to work and making sure that we were really prepared for the challenge, and the task at hand. We wanted to be this well-oiled machine like you see in Formula One, they're working at optimum efficiency. And in order to win a challenge like this, you had to be working at that high level. So the year up to, we had a lot of training within the team, countless meetings. Everyone needed to know their role and what was, expected of each and every one of us. And one big part was rural testing, where in August of last year, we went into rural New South Wales to practice driving the car and simulating what a race would look like. Everyone had their roles and knew what they had to do from, when you wake up to when you went to bed. And each and every individual knew their role inside and out and exactly what had to happen, which is very important when working with a team like this. Each of the individual parts need to work together, otherwise you won't have an operating system at the end of the day.
And it's not just about the actual challenge, right? There's so many more logistics behind, my favorite one is just organizing the sandwiches every morning. That production line is crazy. What's it like to actually organize this from a logistics side of you, to take all of the 35 plus students out to the middle, literally nowhere?
Yeah, like Alistair said, 35 students. It's you don't know if you're going to like everyone at the end of it or at the start, but we're basically a family. Everyone loves each other, but it's tough to be able to get to that point where we are now. And like Alistair said, the sandwiches, you have some picky eaters, you have some people that will eat everything. So it's really about making sure that what we did was available for everyone. So me personally, while there were a few people off working technically on the car each morning, we had a group of 5 or 6 that were in charge of food for the day. So you set up a production line essentially like in a factory where, I was buttering the bread in the morning, and then the next person along will put the tomatoes on, and then the lettuce, and then by the end you'd have, 50, 60 sandwiches for the team for the day. And this was a process that would, started off probably taking 40 minutes every morning, but by the time we got to the competition, we'd be having that done within 15 or 20, because that, practice and getting that efficiency up was all about what we were doing in the lead up to the challenge, so that when we went there on race day, we'd be prepared for everything that would be happening throughout the day, and we weren't wasting time on things that were less consequential. Although everyone does have to eat, so I'd say it was pretty important what we were doing.
It was cutting out the mayonnaise. That was the thing that made all the difference. No mayonnaise.
I like mayonnaise in my sandwiches, Richard.
Well, the journey up, you guys stopped at Uluru along the way and had a nice learning opportunity from there. So maybe Luke, could you just talk us, you actually didn't just drive from Darwin to Adelaide, you drove from Adelaide up to Darwin, and then obviously the competition the way back down. What was the purpose of that? Apart from logistics trying out, what were you trying to do during that journey?
Yeah, so my name's Luke Tedesco. I'm the project officer at Sunswift Racing, and last year strategist, so I study artificial intelligence. But yeah, last year I think the journey, as you say, it begins in early October when we actually left for the challenge. And that drive up, while wonderful and relaxing and getting to see places like Uluru was fantastic, there's also a lot of work going on. And the big thing is kind of understanding the route, understanding the conditions of what we're driving through. I think it's one thing to look at a screen and go, oh, we've got gradient profile, it looks like a mountain, that makes sense, but to actually see a hill in front of you, to see the road wind and turn and change, that's important to know, how the road surface change, how the turns evolve. So really understanding that conditions and understanding what we're going into was really important. And from a data collection point of view, being able to get information about that, about speed limits as well, really was vital to coming back down and knowing what we're coming through, what we're going to experience, and how we're going to kind of address any challenges that come our way.
And I guess part of it is testing out these systems on the road, because naturally using the cloud and things like that, it's very different from being in a workshop. Now, you'll talk a bit more about it in a second, but maybe start with, what are you actually collecting? Everybody's here wanting to know about, what are the IoT, what is the telemetry system, how does that work, and what are you trying to actually collect?
Yeah, so I think we collect probably 3 categories of data. You would say motors, the battery, and the solar generation as well. So understanding those 3 kind of key systems to do with the energy in the vehicle at all times is really important. A good example would be on the track in Hidden Valley when we were doing our qualifying hot laps. It's about 30, 40 degrees there. The motors aren't really meant for that kind of running, so they would start overheating the more and more you ran them. So having the ability to view our motor temperatures and understand what was going on as the car was going around the track was really important to keep, obviously, the driver safe, but also keep the car in ideal condition. So we know when the temperature's going too high, we'd slow down, we'd cool down the motors, and then go back for another run. So having that kind of on-hand, ready information before the challenge and knowing it was there was really important to kind of trust and be aware of for all our strategy decisions.
Definitely. And what you're trying to do is figure out a strategy, I imagine. How does AI/ML play into your team at Sunswift to figure out how you should operate?
Yeah, absolutely. So the Bridgestone World Solar Challenge being such a kind of complex event, there's really a lot kind of going on in terms of inputs, the dynamic conditions, what's going on in the world around you, and that kind of environment. So we use a type of AI/ML called reinforcement learning, which we trained using AWS SageMaker, which allowed us to kind of define that environment and use the data we collected on the way up, that information about speed limits, gradient, the kind of things you can't really find easily. We used that information, fed it to build this simulated model of what the race would look like. And I like to say, before we ran and actually did the race, we'd run it 10,000 times before. And we trained a model that allowed us to kind of have that information, be aware of how fast we should be going at different points in time, and really kind of feed that initial starting point, just knowing what we're going to do, when we're going to do it, and responding to changes. There were dynamic weather conditions, things like bushfires and headwinds that we had to deal with, and being able to respond to that and have someone that had run the race 10,000 times before made it really, really important and really helpful for us all on our first time.
It's obviously trying to do that simulation prediction without having to obviously drive up and down from Darwin 50,000 times.
Yeah.
And I guess that data collection there is really going to help you in future conditions as well when you're using the car in, wherever you happen to be around. Well, Zami, for the technical folk out here, do you mind talking us through that architecture at a high level? What are you trying to do? How does it work? And where are you collecting it?
Yeah, so hopefully as everyone here has realized, Sunswift 7 is a car. Like all cars, we have different sensors on the car that sends data about the car. So as Luke mentioned, it might be things like the battery temperature or the motor speed or anything like that. So that data gets sent to IoT Core, which then distributes that information to the most appropriate services. So for example, we have time stream, and that data is saved as time series data. That's great because it means that we can access that data either immediately or later, and eventually that data is displayed as dashboards in Grafana, and it's shown through SQL queries. So it's an amazing way to get the data to everyone in the team anytime, anywhere. So whether you're in the comfort of your bedroom or actually next to the car, you're able to see the statistics and everything about the car. This is really great for track days, for example. We had one 2 weeks ago at Sydney Motorsport Park. We had Grafana up and running, and it was super helpful because we had this issue with the car. I think it was probably because of the rain, but we were able to see that immediately, and because we could see that, we were able to troubleshoot it, and it's just a great way to be able to prepare for races, and on the race as well, it's really helpful for making strategic decisions for the car.
And I guess for you, Zami, you and your team look after this system to collect the data, but there's obviously almost 90 more people on the team who don't even have to worry about it. They just know that at any one point, if they turn on the car, the data's available for them to understand the battery, to understand the solar radiance, because they don't care about that behind the scenes technology. It just needs to work. And this is what allows you to scale it up and down and put it together. Well, I guess then onto you, Luke. How is that data used? What are you trying to do? And what's the difference between doing it on a track and then you being in the car trying to actually use it and understand that data at any one point?
Yeah, so as I mentioned, there's a lot of kind of forecasting and strategy that goes into it, but also on the race, I was fortunate enough to be in the follow vehicle for the solar car. And being able to kind of an eye on the car is one thing, but in a double sense of having the data up as well, you just really understand everything that's going on at any point in time and can really make those important decisions. So for example, obviously being a very efficiency-focused race, we need to make sure our drivers are driving as efficiently as possible and using the minimal amount of energy to get where we want to go. So being able to view things like the throttle limits, the energy consumption, and have a forecasted rate of energy consumption as well, allows us to look at that, feed back to the driver, and inform them in real time what's going to happen, what they need to do. From a bigger point of view as well, having access to that data, one on the road, but also through the cloud, allowing people back in Sydney to kind of see and respond and view what's going on, gave us this massive wealth of knowledge that I could be sitting on a laptop in the back of a car, but have access to thousands and thousands, I think it was up to by the end of the race, of data, pretty much at my fingertips. So having that kind of access and that ability on the road in conditions that really shouldn't be that easy to respond to was just, really, really important for what we wanted to accomplish.
Yeah, because you're in a convoy. There's so many different teams. There's obviously multiple different cars looking after it. As much as we are moving towards the future where they operate independently, you have a lot of people in this team to make sure that can operate at the edge in the desert, as you saw before, the middle of nowhere. Well, that's a great background about the technology and how it's used. I'm curious for a second. I want to hear about your stories. What was the actual solar challenge like, and what did you get up to? So I have the same question for pretty much all of you. I'll start with Daresh. What was your favorite part of the actual whole solar challenge?
Yeah, it's pretty difficult to pick just one because the whole thing was an experience that I'll definitely never forget. 25 days out in the middle of the desert with your mates, just driving a solar car down Australia. It's not something that everyone can say they've done, and it's definitely very memorable. But for me, one of the highlights was that qualifying session up in Darwin, Hidden Valley Motorsport Park. I was very fortunate enough to be the driver for that lap, and I'm a huge motorsport fan, so this was a great opportunity for me. But it shows the sort of just the breadth of engineering, and one of our biggest advantages was how strong of a car we put together in the 3 years leading up to this competition because we were able to push it to its absolute limit. And this solar car, if you go out and check it on the floor afterwards, it doesn't look like your normal road car or your normal race car even, and it's quite different. And to be able to push it to its limit and have it hold up over a lap, which is not designed to do necessarily, gave us a huge edge for the whole competition, because being able to qualify first allowed us to stay ahead and manage our strategy in the way we wanted it to be managed, which is a huge advantage the whole way throughout the competition. But another huge part of that qualifying lap was how special it was that it was live streamed, thanks to AWS, all over the world. And my friends and family down here in Sydney were able to follow that lap with us. There was almost like they were in the car with us, and I got home and that night I got back to where we were staying, my mum texted me, I followed the lap, great job, well done, which was really special. It's kind of crazy how AWS allowed us to do that from thousands of kilometers away in live time with such limited architecture out there, especially in the desert. As we followed through the journey, the whole live stream aspect of it was very cool. But also just another sort of different type of highlight for me was driving through these remote country towns, and you see all the people lining up on the sides of the road looking at us. And I think it's a very good looking car, and obviously they seem to agree as well, because they were lining up to sort of see or catch a glimpse of us. It's not often you see a car that looks like that driving down with a whole convoy of other vehicles alongside it as well. So it's, again, something I'll never forget.
I remember driving out of Darwin, and just for kilometres on end, we'd keep going, and there'd still be people sitting on the back of their utes, smiling, waving, celebrating the actual challenges that are people who are actually in the team. Wonderful to see. Same question to you, Luke. What was an amazing part of the journey for you?
Obviously everything Duresh said was great as well, but to focus on something slightly different, as Sammy said before, it's a bit of a world engineering forum, right? You have, as we've mentioned, so many different disciplines that combine to work on a car like this from 30, 40 different countries. Even within our class, we had Americans, Estonians, Taiwan, Hong Kong, all these different countries participating. It was a really great opportunity to just meet these people from the beginning at Hidden Valley, looking down the pit lane and seeing everyone's flags and all these different countries being involved. But then also a good example was in Coober Pedy. When we got to Coober Pedy at the end of day 4, we went to an outdoor cinema. I think it's the last outdoor cinema in South Australia. They played The Castle on TV, which is lovely for all the international friends. And we played cricket with some of the Americans, and it was just this really, really wonderful experience, something really unique to just kind of meet with these people, discuss with these people from such different backgrounds. And yeah, really, really enjoyable time.
Well, we're touching on that team aspect. I think you had something special that week. Did I hear it was your birthday on the Thursday of the event? What happened that night, or at least that morning?
Yeah, so I was lucky, I do mean lucky, enough to have my 21st birthday at the beginning of day 5, so the morning in Coober Pedy. And that was, a little unique. So in Coober Pedy, as many of you may know, we usually sleep underground, just it's a bit more climate controlled. So we're underground in this kind of tunnel system with different outcroppings for each of our tent groups. And I'm lying in our stretchers, which are just like raised off the ground to allow us to sleep. And I'm lying there and I hear people talking and shuffling around. I'm just thinking, okay, they're gonna jump me, it's gonna be like, boo, wake up, and I'll move on with my life, but I'll let them have their fun. So I'm lying there, I keep hearing shuffling, I'm just kind of cracking one eye open, and then I actually look up, and suddenly there's people at either end of my stretcher. I'm like, what's going on here? And then 3, 2, 1, up I go, and suddenly I'm in my sleeping bag, in bed, on the move. They bring me outside, leave me under the bright morning sky. Thank you, Richard, for recording it instead of stopping them.
Pleasure.
I do appreciate that. But yeah, definitely, at the time I was more thinking, Coober Pedy is very dusty. How am I going to get back to my shoes? But looking back, it's definitely, I'm not going to forget my 21st anytime soon.
Absolutely. And I think that team spirit really continued, because naturally you can't take everybody on the road with you, right? Zami, you were back here in Sydney at RaceCube. What was happening here? How were you contributing to, and how did AWS help you actually do that back at home?
Yeah, so again, we can't have all 80 of us in the middle of Australia. So some of us were back home at RaceCube. RaceCube was this huge glass contraption right in the middle of our main walkway where everyone in the uni could see it. It was amazing because it was sort of like our control center. We had huge monitors, we had screens, TVs, that was displaying our Grafana dashboards, it was showing live streams that AWS helped us with. So it was an amazing opportunity for us to, come together and actually see the team as the race was unfolding. So in no way did we feel like we were left out just because we were at Sydney. It felt like we were there with the team, experiencing like their passions, their highs, their lows, all of that. So it was really great to experience. And I think RaceCube was one of our strategies, our main strategies, because it really helped us. We could see the data, we could help the team make strategic decisions. I think one of the days there were bushfires, head-on wind, construction, and these obstacles would be kind of tricky to maneuver if it weren't for us being able to forecast them and tell the drivers something's coming up ahead, you should probably try to work around it. So yeah, it was a great opportunity to show off the technology that Sunswift has. I think there were so many other students coming in, there were members of parliament, there were reporters, there were industry members. It was just amazing to show off Sunswift and what it does and experience it along with the team as well.
And to Richard, maybe that was a competitive edge thing that you came up with, and how did it enable you to get a benefit over the competition and actually enable you to go on to the result of this tech?
Yeah, look, it's something that's sort of copied, it's a bit of a NASA thing maybe. It's a bit of a very much a Formula One thing these days to have that sort of mission control off-site, and I think that what that allows us to do in quite a chaotic environment, and certainly for the guys on the race in the back of albeit a nice air-conditioned Audi, sometimes to have that sort of mindset is a bit of a challenge. So if we can take that heavy lifting away and put it onto the guys in Sydney, yes, it was a bit of a showcase, but it was creating that competitive advantage. It was that point of difference. And certainly to have that technology at our fingertips, we wouldn't have been able to do that, Alistair, even 2-3 years ago. Actually, to take that information from the centre of Australia, it's maybe a little bit easier from doing it from the surface of the moon these days than it is from the centre of Australia. So one, it was a technological challenge for us to enable us to do that, but really the benefits of doing us really gave us that edge over all the others.
Absolutely. But data wasn't the only part of that. You had a live stream the entire time. How did you feel about that, and how did that make you feel connected for control, strategy and so on, but then for everybody else experience the journey along the way?
Yeah, I really think AWS did the hard part for us. They would capture it all on the live stream and they would just distribute it to YouTube, Facebook, Instagram, whatever we wanted. So it was a good opportunity to catch up with people from the night before, see what they got up to, and again, broadcast it to the world, tell everyone what we're doing and the potential of what students at university can do.
Yeah, well, I had to be slightly useful during this journey, so I had to be a bit of a producer by the scenes, and we got to experience all of the students talking about their journey throughout the day. It was almost like a morning and night show. You had what was going to happen during the day before it started, then during the race everybody got to watch it live. We got messages on the road being like, what was that? Where'd you go past? That looked really cool. And naturally in the night, we'd drive up to somewhere, we'd get our camera out, we'd set up a few lights just so we got to hang out with everybody and just talk to everybody. So we brought everyone for the journey. And how did that feel, getting to see everybody's reactions all the way back at home at RaceCube and probably in bed by that point?
Yeah, no, it was nice. Again, just a nice way to really stay connected. Hopefully if the team in Darwin felt like they were being supported as well, because half the team is in Sydney, but yeah, it was just really great opportunity to actually see live what everyone was up to.
It was nice and easy. Media Live, that the service there really just took all the footage, no matter what camera it was coming from, and immediately just streamed it to your socials and everywhere around the world. I think we've held everybody in suspense about actually the result of it. Maybe I'll go to you, Duresh. Tell us, how did it go? What was the result?
Yeah, at the end, we not only crossed the finish line first, which is an amazing achievement in itself, but our cruiser class is about more than that. It's about practicality and desirability. We want to present to the world a vehicle that, can be in industry, a vehicle that people want to purchase. So, you take the scores from that, you add it all up, and at the end of the day, we were successful. We came first in the competition, all things considered, so it's an achievement we're all very, very proud of. It's 3-4 years in the making, and it's something that we'll definitely hold on to for a very long time. All the team members, not just currently in the team, but before us as well. It's been really leading up to this moment, and the fact that we were able to show off what a group of undergraduate students can do in the world stage like this is just a huge and remarkable achievement that, again, we're all very, very proud of. It's able to show industry what can be done. If undergraduate students can do this, why can't big car manufacturers? The way that the industry is moving is towards vehicles such as this solar-powered cars. So to show that they're not only achievable but practical and desirable as well is something that we all strive towards, and that's the whole aim of this cruiser class competition. So again, very, very proud of the result. Being able to come first is the first time that an Australian team has won this class, this category. So it's an achievement that we'll definitely hold on to for a very long time.
And I think that's a general misconception. Everybody talks about this as being a bit about a race, but it's very much not that. You had the judging at the start, you had judging at the end, naturally had to do a lot. Can you talk to us a bit more about what makes up the points? What process did you have to do to actually get the result that you came out with?
Yeah, for sure. It's quite a convoluted formula, in fact, to come up with the final score, but the main parts of it are efficiency, practicality, and desirability, essentially. So efficiency, it's about how little consumption you use, and if you have a look at our car, you'll see it's a 4-seater car. So obviously the more people you have in the car, the heavier it is, the harder it is to go a further distance. So the more people you do have driven in the car over a certain number of kilometers, the more points you do get. So being a 4-seater car, we were very adept at getting those points because it's better to have 4 people in than to have 2, for example. But then again, there's also the practicality. So we have a group of judges at the end who come by and see our car, looking at all the features that are available to it, because at the end of the day, you want a car that's comfortable, a car that's easy to drive and will make your life easier by being able to drive that. Hence why all these cars are moving towards automotive driving, self-driving cars, because they want to make our life easier. Obviously we can't do that in the middle of the desert in this car, but we put in a bunch of features to make our lives as drivers a little bit easier compared to what might already exist in cars such as this. So when you combine all of those scores together and you add them up, that's how they sort of decide which one's the best overall car for the cruiser class. At the beginning, the efficiency, how much charge you're putting in, how much you're drawing from solar instead of versus your battery pack, and of course how desirable and practical it is at the end of the day.
And of course, as a driver, you want to be comfortable. That's a long journey along the way. You don't want to be sitting in a tiny little cardboard box squished up. You actually want to have a vehicle that's usable for the future. No,
for sure. We have a lot of people asking about how it is to actually sit in that car. And, it may not look great, but trust me, it's actually a lot better than it looks. There's plenty of periods where I was asleep in the back because you can sleep in the back. It's pretty comfortable. And, so that's sort of what we're aiming for. As a driver, personally, I'd love a comfortable car, and it might not look it, but believe me, it's great.
That's fun. Well, obviously, this is not the end. You may have already broken a world record for the fastest car to travel 1,000 kilometers under a single record. Now you've won the Bridgestone World Solar Challenge. But Richard, what's next for the team? What are you trying to achieve?
That's a really good question.
I leave the hard ones to last.
Yeah. Look, the team has been on a journey for the last 27, 28 years, and we've taken the project from once was an extracurricular student-led project. We've embedded it within the curriculum, and with incredible learning outcomes. I don't think any of these guys would have the level of learning that they get being involved in Sunswift than they ordinarily would. I've got to say UNSW are amazing. They pay a little bit of my mortgage. So I've got to say that they're good, but Sunswift just gives this extra dimension. And you're right, look, we've got a few Guinness World Records under our belt. We've now won the Bridgestone World Solar Challenge for the first time. So it's exploring what's next, and what's next is really quite exciting. We've made the decision to build our next car, Sunswift 8, which is going to be road legal, whereas Sunswift 7 currently isn't technically road legal. Sunswift 8 will be straight off the bat. Not only that, it will be Australia's first hydrogen-built car. It will also be the world's first tri-bred. So that's a combination of solar, battery, and hydrogen power. So a really great departure from what we've been doing, and the next big challenge. What we always aim to do as a team is not repeat ourselves, always to innovate, always to move forward. And I think for me, for these guys, if they can come into the workshop every single day not knowing how to do something, but then leaving the workshop at the end of the day knowing how to do it, I think that's education. Correct me if I'm wrong. Absolutely. If we do it as a team and as a project, and if we're constantly growing, well, that's innovation. And if we can do that through great partnerships as well, through the likes of AWS, then we're all benefiting. Sunswift 8, we're giving 10% off if any orders come in today. There's a fairly large deposit. But hopefully this is the next move forward for us.
And naturally, when should we expect this? How does the team put this together over the next year as students come through and take part in the subject?
Look, we're about halfway through the design phase at the moment, unless Suresh is going to tell me we've fallen behind and he's waiting for this moment to say the project's not on track. But yeah, about this time next year, Sunswift 8 will be turning its wheels for the very first time. Look, it's great collaboration, and as we've said before, this is a unique experience where we put mechanical and electrical and computer science together all in the same room. And really it's what they're going to experience in industry. And look, I'm non-academic. I'm a professor of practice, but I run this like a business. I run it like a Formula One team. We're a high-performing group of individuals. So they're learning all the elements which goes towards building something quite impressive like this.
Absolutely, and we look forward to seeing the challenge you bring us that we can help you solve as we move forth. Well, again, thank you all for coming to our presentation, and thank you, team, for actually sharing your story. It's been an amazing experience being able to show you how all this technology can be used in practice at the bleeding edge. For everybody here in person, we have the car out the front right near the entrance. So if you haven't already seen it, please come out and you'll be able to ask these amazing students and Richard these questions about anything you have on your top of your mind. For those also here, but also at home, now on YouTube, you can see the full case study at what it actually was like to travel from Darwin to Adelaide and how the technology really helped them. Thank you all again very much for joining us, and we hope you have a great rest of the summit. Thank you all, and thank you guys
everyone.
again.
Thank you.
Well done, guys. Awesome.
Thanks very much, team. It's great to see some very smart minds working on some very tough problems. There is feedback, so do take the time to provide feedback. We really appreciate that. This is the last session in here today, but there's plenty of other sessions happening within the other rooms, so certainly check out those ones. Thanks very much.